A set of vectors is called linearly independent if none of them is secretly redundant, meaning the only way to combine them and get the zero vector is to use all zero coefficients. If some other combination also gives zero, the set is called linearly dependent because at least one vector is hiding inside the others. The test is always the same. Take the combination C1 times V1 plus C2 times V2 plus and so on, up to CK times VK, set it equal to the zero vector, and ask whether zero coefficients are the only solution. Let's work a complete example in 3 dimensions. Let V1 equal the vector 1, 0, 0, let V2 equal the vector 0, 1, 0, and let V3 equal the vector 1, 1, 0. We write the equation C1 times V1 plus C2 times V2 plus C3 times V3 equals the zero vector 0, 0, 0. Now convert this vector equation into a system of ordinary equations by looking at each coordinate separately. The first coordinate gives C1 plus C3 equals 0. The second coordinate gives C2 plus C3 equals 0. The third coordinate is automatically satisfied, since every vector has a 0 there. To solve, pick a value for C3 and see what happens. Let C3 equal 1. Then from the first equation, C1 equals minus 1. And from the second equation, C2 equals minus 1. So we have found the solution. C1 equals minus 1. C2 equals minus 1. C3 equals 1. This is a non-trivial solution because not all the coefficients are 0. Since a non-trivial solution exists, the set V1, V2, V3 is linearly dependent. One of these vectors really can be built from the others. Let's check this by plugging the coefficients back in. Minus 1 times V1 plus minus 1 times Vi2 plus 1 times Vi3. Minus 1 times 1, 0, 0 gives minus 1, 0, 0. Minus 1 times 0, 1, 0 gives 0. Minus 1, 0. And 1 times 1, 1, 0 gives 1, 1, 0. Add in these together, the first coordinates give minus 1 plus 0 plus 1 equals 0. The second coordinates give 0 minus 1 plus 1 equals 0. The third coordinates give 0 plus 0 plus 0 equals 0. Everything cancels, confirming the dependence. This 4-step process, write the vector equation, convert it into a system, solve the system, then interpret the result, is exactly the same test used everywhere else in linear algebra whenever independence needs to be checked. Like and follow for more math tutorials, one idea at a time, nothing rushed.